Heat engine is a device that converts the supplied heat into work. So the major job, what is the job of a heat engine is that do some work using the supplied heat energy. Using the supplied heat energy. So you will be converting heat into work, and that is nothing but a conservation of energy. But one important point that you need to understand is all supplied heat cannot be converted into work simply because heat is the disordered form of energy. It cannot be oriented and convert completely into work. There is some part of supplied heat get wasted. Here in the system it is called like it is passed to a device, to a part of the heat engine called sink. So when you say some heat energy has gone to sink, it means it is actually wasted. So what we can say is a heat engine can have broadly three parts. A heat engine has basically three parts. What are the three parts are? One is source, right? Source is somebody who supplies heat, any kind of a coal or something like that. Then it will do some work for us, right? It will do some work for us. So the dq you have supplied, q you have supplied, otherwise it will do some work for you. Remaining heat energy will be passed to a part called something like sink. Q2, you can call this as Q1. So as per the law of conservation of energy, the supplied heat has done some work and remaining one is passed to sink. That's a heat engine. From here we can further say the work done by a heat engine as heat supplied by source minus heat rejected to sink. Work done can be written like Q1 minus Q2. So if someone asked you how efficient this system is, to measure that we have a term called efficiency. As the name itself tells you, it is how much of the supplied heat is able to be converted into work, right? So we can say efficiency as work done by heat supplied from the source level. See, if heat engine is ideal, if all heat supplied is converted into work, then efficiency is both of them will cancel, numerator and denominator equal to 1. Having efficiency 1 is not possible. Only for an ideal heat engine efficiency equal to 1. Because we have a sink, work done is always less than heat supplied. So in real life, efficiency is always less than 1. Of course, if it is 0.9, that means 90% of the heat is converted into work and vice versa, then that is a good heat engine, and vice versa we can say. Now I can further write efficiency as work done in terms of heat energy as heat supplied by the source minus heat rejected to the sink. sink by heat supplied with the source. We can also express efficiency as by dividing with Q1, 1 minus Q2 by Q1. This is the way of expressing efficiency. Each of these heat energies will have a temperature towards them because these are all based on ideal gas. Instead of that efficiency, I can write it in terms of temperatures. But be careful, they are in absolute values, absolute temperatures. You shall write them in only Kelvin, not in any other unit. So here T2 is temperature of the sink, T1 is the temperature of source. Thus the efficiency of a heat engine can be expressed either in terms of heat energy or in terms of temperature. Heat engine is a device that converts the supplied heat into work. So it cannot be ideal, it cannot have an efficiency 1, it will be always having an efficiency less than 1. Thank you for watching.